Morning everybody. Next is the problems in photochemistry. First problem is the intensity of the monochromatic radiation is found to be reduced to 1/3 of the initial value after passing through 8 cm length of 0.05 solution of the substance. Calculate the molar absorption coefficient of the substance. So the Beer-Lambert's law in this chapter is very important, both the equation and the problems. So first of all, in the question it is clearly given that the intensity of the monochromatic light is reduced to 1/3. So the Ix is 1/3 of I0. And after passing the 8 cm length, L is given 8 cm and concentration is given 0.04 molar concentration. And the question is we have to find out the epsilon. That is the question. So in every problem we have to convert the every data which is given in the question to the SI unit. But remember that in this question cannot convert the length to the meter because the definition of the Beer-Lambert's law is explain the length of the cuvette in terms of centimeters. Okay, now we are moving into the problem. First of all, you write the Beer-Lambert's law, log I0 by Ix is equal to epsilon Cx. And here it is given in the question itself, Ix is equal to 1/3 of I0 and C is given 0.05 mole liter inverse, X is given 8 cm. So direct substitute the value, we will find out the epsilon. We have to study the unit. If you are forgot to write the unit, we will reduce half mark. Okay, so that's why the unit for epsilon is liter, mole inverse, centimeter inverse. Next problem, a 0.01 molar solution of a substance absorb 10% of the incident monochromatic light, a path length of 1 cm length. What would be the concentration of its solution if it absorbed 90% of the same radiation in the same path length? So this type of the question we have to read the question very carefully. They are given the concentration 0.01 molar the solution, and it is given in the question that it absorbs the 10% of the incident monochromatic light. So Ix is equal to 10% is reduced, so remain it is 90%. So that's why Ix is equal to the Ix is 100% and I0 is 100% and Ix is 90. And if the path length of the L is given 1 cm and our question is what would be the concentration of its solution if it absorbs 90% of the same radiation. So in second case Ix is equal to the 90% of the I0. That means Ix is only 10, I0 is 100%. Now we are moving into the problem, the solution. So first of all we have to write the Beer-Lambert's law is log I0 by Ix is equal to epsilon Cx. In our first case it is given the only 10% is absorbing. So I0 is 100 and Ix is 90. That's equal to epsilon C1 into X. C1 is given, that is 0.01 mole liter inverse, and the path length is given and epsilon is a constant. In second case, they are given that 90% is absorbed. So I0 is 100 and Ix is 10, only 10. That's equal to epsilon, that is a constant, and C2 into X. So we have to find out the C2. Then dividing the both equation, we will get log 100 by 90 divided by log 100 divided by 10. That's equal to C1 by C2. C1 we know, we have to substitute that value. Then after the balancing the equation, we will get the answer is C2 is equal to 0.2183 mole liter inverse. Then now we move into the third problem. I think The third problem, it is not given in the presentation. I will read out the third problem. An aqueous solution of an organic dye in beer cell absorbs the 10% of the incident light. What fraction of the incident light will be the same solution absorbed if a cell is 4 times larger than the first is used? So in the question itself, it is given, first of all, it absorbs only 10% of the incident light. So Ix is equal to 90. I0 is 100. What fraction of the incident light will be the same solution if the cell length is 4 times larger than the initial one? Now we are moving into the solution. First of all, you have to write the Beer-Lambert's law. Log I0 divided by Ix is equal to epsilon C into x. Then substitute I is equal to 100 and Ix is equal to 90. Then epsilon into C into x. Log 100 divided by Z, that is in the second case, that is equal to epsilon C into 4x. Then we divide both the equation. We will get log 90 by Z, that is equal to log, that's equal to 1 by 4. Then by rearranging, we will get the Z value, that is 65.38. But we have to find out the percentage of the absorbance light. So we have to reduce this value from 100. So 100 minus 65.58, that's equal to 34.42. And the fraction of the light absorbed, again we have to convert this value into in terms of 100. So 34.42 divided by 100, that's equal to 0.3442. Next problem is the fourth problem. A solution of an organic dye in water absorbs 20% of the incident radiation in a path length of 2 cm. What percentage of the same incident light would be absorbed if the concentration of the solution is doubled for the same path length? So in the question, it is given that in the question that 20% of the incident light is absorbed. So the the Ix is equal to 80, and for the C1 is the concentration. After that it is multiplied by 2. Okay, doubled. That means 2C1. So substitute the equation log 100 divided by 80, that's equal to epsilon C1 into x. In second case, log 100 divided by Z is equal to epsilon 2C1 into x. So direct substitution, we will get the Z value. After that, for finding out the percentage of the light absorbed in the same case, we have to reduce this term 64 from 100. So we will get 36 as the answer. So next problem, this is an this type of this question is asked in the competitive examination. At 460 nanometer, a blue filter transmits 70% of the light, and yellow filter 41% of the light is transmitted. What will be the transmittance at the same wavelength of the two filter in combination? That is the question. So they are given in the graph or figure. In first of all, we are passing I0. Intensity of the light of the initial light is I0. First of all, it is passed through a blue filter. So the light which is coming from the blue filter is I1. And after passing this I1 to yellow filter, we will get the intensity of the light which is coming out is I2. So they are given in the question that 73% of the light is transmitted. That is I1 by I0 is 73%. That's equal to 0.73. And in the second case, I1 is the initial, the incident light is I1, intensity of the incident light is I1, and transmitted light is I2. So I2 by I1 is equal to 41%, that is 0.41. So therefore I2 by I0 is equal to I2 divided by I1 into I1 divided by I0. That's equal to 0.41 into 0.73. That's equal to 0.2293. That's equal to 22.93%. So here we discussed the problems in Beer-Lambert's law. So in university question they will ask by changing the intensity of the light, or changing the concentration, or by changing the path length of the cuvette, or sometime they will ask the epsilon.